Alright, so as you can see that there are no guided notes for today. You need to get out a piece of paper and take notes on your own today. So there will be no notes attached to my website. You will just be writing them down on a sheet of paper. So if you need to, go ahead and pause the video and get out something to write with, a piece of notebook paper, as well as your calculator. Alright, so as a refresher, we'll be talking about tangent. Remember that tangent is opposite over adjacent. Alright, so looking at this problem here, I want to find the tangent of x and the tangent of y. So, first off, I'll start with x. Here's angle x. This is hypotenuse, opposite, and adjacent. So tangent is opposite over adjacent, so 13 over 84. If I put that in my calculator, it's not going to simplify anymore. It's in its simplest form. Alright, so then I erase this and say from the perspective of angle y, this is still the hypotenuse because it's still across from 90. However, this is adjacent and this is opposite. So the tangent of y is really going to be 84 over 13. Notice that with the two complements, angle x and angle y are complements of each other because they add to 180, that these fractions are flipped. And when we call them, what we call them when they're flipped are reciprocals. So the tangent of an angle and the tangent of its complement angle are reciprocals of each other. Alright, so just as before we used our calculator to find sine and cosine of various angles, you need to do the same with tangent of 22. You're going to hit tan, which then leaves you like this, tangent with a bracket, 22, close your parentheses, and what you're going to get, you need to round to the 4 decimal places. So I got 0.4040. Alright, in this problem, we're going to need to use tangent to solve for x. Notice that we do not have the hypotenuse. So from this angle, x is opposite while 15 is adjacent. We don't have the hypotenuse, we're not looking for the hypotenuse, so we're going to use tangent. Tangent of theta is opposite over adjacent. So the tangent of the angle, 28, is equal to x over 15. When x is up high, you multiply. So to get rid of this divide by 15, I would multiply both sides by 15. And x needs to be rounded maybe? Doesn't say. Alright, so when I type it in my calculator, I get 8. So I'll round it to the nearest decimal point, 0. Alright, what I'd like you to do is take a minute and try this problem here, please. So go ahead and pause the video, give it a shot. Alright, so from this angle, I need to label the opposite and the adjacent and the hypotenuse. I'm not given the hypotenuse, I'm not looking for the hypotenuse, so I'm going to use tangent. Because tangent deals with opposite over adjacent. So the tangent of 32 degrees is equal to 24 over x. When x is up high, you multiply. When x is down low, you divide them, you know. So since x is in the bottom, down low in that fraction, I'm going to divide 24 divided by tangent of 32 rather than multiplying them. So I will get 38.4, and the units of measure here is feet. Now I'm not only asked to find the value of x, but I'm also asked to find the area. So if you've not found the area of the triangle yet, here's the formula. Please pause the video and give that a shot there. Alright, the base for my formula is x, so I would use 38.4, and the height would be 24. So multiplying that in my calculator, I get 460.8 feet squared. Remember that area is squared because we had 38.4 feet times 24 feet. So feet times feet is feet squared. Alright guys, as you know, sometimes I throw in little random tidbits about me and about my life. So today's little tidbit is actually about my lunchbox, as crazy as that sounds. Anyways, my lunchbox is Bear Bradley. This is one of my favorite patterns. It's called Plum Crazy. You guys probably think I'm plum crazy for telling you about this lunchbox, right? But anyways, if I ask you about the pattern on my lunchbox, I'd expect you to say plum crazy. Alright, I'll see you guys. Alright, so here's a real world example. We need to find the height of this lamppost. Now you know it's really hard to find the measure of these things. Sometimes our measuring tapes aren't long enough. Sometimes it's just awkward to try to climb to the top of a lamppost and figure out how tall it is. I'm pretty sure if a cop saw you doing that, they'd be like, what are you doing? I'm doing some math. No, that won't work, okay? So we can find the height in a much simpler, civilized way, if you would. So what we have over here is 68 degrees, and I need to label all the sides. So the height of the pole is going to be the side opposite of 68. 38 inches, or my distance away from the pole, is my adjacent. Notice that the hypotenuse is here, but we don't have it, we're not looking for it, so I'm not going to use that. Since it's opposite over adjacent, I will be using tangent, because tangent is opposite over adjacent. So the tangent of 68 degrees is the opposite over adjacent. So my variable's up high, I'm going to multiply to get the height. So take a minute, type that in your calculator. Make sure that you round to the nearest inch, so it's not any decimals are going to happen here. So the height to the nearest inch is approximately 94 inches, because we had to round to the nearest inch, not nearest tenth of an inch, we rounded to the nearest inch. Alright, now sometimes finding the height of a tree can be pretty tricky. So what we have here is a random tree. I know. Let me move it up for you. Bloop. There, now we can see it with all the definitions and the directions and all that kind of stuff. There we go. So yes, obviously your trees don't walk. It'd be really hard to measure them if they were walking all the time, right? It's kind of like getting a 2-year-old to get measured. They won't stand still long enough. Anyways. So this is just a random picture of a goofy tree, but we're going to find the height of this tree. Let's say that we're standing 100 feet away from it, and the angle of elevation, I'm looking up to the very tip top of the tree, and that is 48 degrees. So I'm looking for the height of the tree, which is my opposite side, and 100 feet will be adjacent. So we're going to use tangent here. So the tangent of 48 is opposite over adjacent. The variable is up high, so you will multiply. So that's a weird looking 100. 100 times tangent of 48 equals h. So there's no directions as far as rounding. However, I do have feet. So let's do 111.1 feet. That is the height of the tree, the walking tree. Basically, how you would find the angle of this 48 degrees is with something called a clinometer. And if we have time to get to it, we will have a day or a couple of days where we create our own clinometers, and then we will measure certain things, buildings, trees, lampposts, in real life. Okay? So be prepared to be able to solve problems like this. Tangent will be used pretty exclusively when we talk about that, because we won't know the distance of this hypotenuse here. So just make sure you're getting the math, because you know sometime by the end of this semester that we may be doing this clinometer project, and you may go, oh well, I didn't really pay attention. Okay, you need to. Okay, so if we're struggling with this, come see me, because this is very, very, very important. Alright, and last but not least, let's try this problem here. I want you to find the tangent of A, sine of A, and cosine of A. So ignoring the directions for now, I want you to find tangent A, sine of A, and cosine of A. Alright, so pause the video and take a minute and do that now. Alright, so from A, we need to label the sides, adjacent, hypotenuse, and opposite. So tangent is opposite over adjacent, that's 3 over 4. Sine is opposite over hypotenuse, 3 over 5. And cosine is adjacent over hypotenuse, so 4 over 5. Now the directions said to actually divide sine and cosine. So I'm going to divide these two fractions together. And if you type it in your calculator, you can do a fraction inside of a fraction. And what's actually going to happen is that you get 3/4. Notice that this is the same as tangent A. That's because the tangent of any angle is equal to the sine of that angle divided by the cosine of that angle. Kind of an interesting little fact there, isn't it? Alright, well that's it for tangent. So we've completed sine, cosine, and tangent, and I will see you guys later.